document scoring, 1,000-fold speed up, high accuracy compared with Uni-Dock vina, and then supposedly outperform report accelerate document programs include Uni-Dock GPU and vina GPU. Demonstrate improve performance, and then they actually like dock 38 million molecule, pretty crazy, in 12 hours. Using 100 V100, that's pretty insane. Nice. In the paper they go a bit more into detail, but this whole thing is working. So let's look at this. Yeah, it seems to be a pretty strong this seems to be they're doing some tricks with loading points, and then I think overall it's pretty clear that the docking function is pretty comparable. Definitely recommend giving this a read. The API seems to be pretty straightforward too. So it requires PDB-QT inputs. Then you point it to a set of ligands where you have one ligand in the PDB-QT file. And then it uses vina as a scoring function. Now we'll take a look at this code and start working on actually containerizing this. Okay. I already started working on this a bit, but we actually do have on my machine I already installed Uni-Dock. I think I did at least. Let's just clone it again one more time. Okay, so we have Uni-Dock over here, and then it turns out that actually what's necessary to get it all to work in our case is the binary. So we actually need to download the binary here. They do have, I think, some installation instructions here. Okay, so let's check out the releases. They seem to have two different versions of support. The 84. So let's go here and copy the virus. And we'll go back here and we download that binary. Okay, so it seems like it's out there. I don't expect it to work on my laptop because I don't have a Mac. I have a Mac that doesn't support NVIDIA. So what I'm going to do is I'm going to create a Docker instead and execute that Docker on a machine that has an NVIDIA GPU and the required Docker runtime for NVIDIA. Okay, so in order to do this, the next step is to switch to our repository with PLEX. And I'm just checking here. I'm already on this at Uni-Dock branch, so I can open this in VS Code. So we're going to add a tool here. We're in the tools directory, and basically what we're going to be doing in our project here is we're going to add this Uni-Dock. So we already have this thing. I'm going to move this in here. I can rename it slightly. And then we just have some example files here. We have some example. So this is the example protein. I'm not sure whether we have an example small molecule as well. These all look like proteins. Not sure what we have over here. We'll have to see. Okay, so what we need to do now is we need to set a Docker file, because basically we now want to install the whole thing, the whole binary on an Ubuntu instance. So it doesn't seem like there was a lot of information here about what was running. Okay, let's go back here. So I think we're just going to default to Ubuntu in the absence of that. So I'm going to just take a shortcut. I'm just going to look at what type of okay, so it supports this on Linux. So we learn more about what exactly the requirements are beyond the fact that we need the CUDA toolkit itself, which is really only what we need. 12.1. Okay, let's see. Let's pick so a container that has CUDA 12.1. These are the CUDA images, and let's just see whether we're at 12.1 over here. So we got CentOS version. That all of these versions are super recent. I'm a bit worried that we might just have something that's a bit too early. It might give us problems down the line. I guess we're just going to give it a try. Okay, so we're going back to our Docker file, and we're referencing this Docker file. Let's just do some boilerplate over here. Now, what we can probably do is we can probably create a template Docker file to make things a bit easier for everyone as their containerizing tool. So I'm just going to add that as a takeaway from this. Okay. Pull up this image over here. So we don't need to copy the requirements because it's not a package per se. Instead, yeah, we just copy some of the base information that we need to do. The install command for our binary. Let's just use the one that has the 84 in here. Probably need to make sure that need to probably install wget in here. Just replacing this placeholder with something that's this apt install instruction with something that runs in line. So we install wget. And then I think the document should already be ready. So let's try this out. Let's check the instructions here one more time. Be good. So then let's build this thing. All right. Uni-Dock. In order for this to work on your machine, you need to install the Docker plugin for VS Code. But you can also obviously build this through a different mechanism. You also want to have Docker installed on your machine. I'm just waiting right now for my Docker engine to boot up. It's happened. So then let's give this another try. That seems to work. So it now pulls the container from the registry. That will require some time. And then we probably want to already start with the next step, which is to actually create a tool for PLEX. So while we're doing this, we want to create a new file that we call Uni-Dock.json. And this is what we call a command line tool. So this is, we call this Uni-Dock. A command line tool is the current basic class of tools that we support with PLEX, and it basically has always elements. It has a set of descriptions, then it has the base command and the command line arguments you're running. It then has a link to a Docker file, some hardware requirements, whether you need a GPU or not, and then a definition of your inputs and your outputs. So this particular case, I'm starting us off with like a different tool. So we need to like remove some of these pieces over here. Clean that up. And then we can also add a Docker reference moment once we have a container. We will definitely need GPUs. And although I don't know whether we need networking, I might just end it for now. We do need a protein here, so we will create two inputs. One that we expect is a protein, and we actually want it to be in CBQT format, and then we also want to have a molecule, and we're expecting that, I think, to be in PDQT as well. And then as outputs, I actually don't know what type of output we're expecting. So let me just pull up the outputs that we expect. We have a receptor. We have a search mode. So that's another parameter that we're going to be adding to the tool config. Here. Really very keen to hear your feedback and how we can make this easier to follow.
I am recording this.
Or if you have any questions, let me know.
So hopefully.
Nice.
But
Okay.
I'm a little bit skeptical the sound is going to work, so don't get too excited. It may just be a video of you typing things.
Oh no.
We'll see.
Okay, that's fair. That's fair. Okay, I'm just going to create a default here. The default is balance, and I think type will be string. We didn't fully come up with this standard to define a tool. There's actually a standard that's called CWL, the Common Workflow Language, and we're taking a lot of inspiration from there. There are three parameters: the protein you pass in, the small molecule, and then there's a search mode parameter that is a string, and we just define a default. And we're going to get that in just a moment, how that all looks like. So let's look at the output that we're getting from all of this. So we can specify a thing box, and then we can specify an output directory that's going to be important. And we don't yet know exactly what's going to be returned, but I guess we'll just have to what. Here's an example file. Let's take a look at this. This is the test that we saw. I can't fully understand the example right now, so I guess we'd have to take a look at run doc itself. Let's see what we got there. Okay, so it seems like we have some kind of base configuration for each run. That's cool. Nice. And then we have some kind of Python script that seems to decompress a ligand set. Then to read and construct a command. Does some benchmarking of the time that it takes, and then return a nice CSV file. It seems to contain scores, and then it seems to be with this dude in the benchmarking data set. Okay, now let's go back to the Uni-Dock config. Don't really know what to expect here for now, so I'm just going to leave this empty, and we'll see what happens. Okay, so in the meantime, our attempt at building this container is continued. All right, something trivial seems to have gone wrong. apt get, oh yeah, it's because we were using CentOS. So let's go into the Docker file. I think we need to do we need to actually do the yum. Let's see whether this is working. Otherwise, we might just have to ask ChatGPT. Taking a shortcut here. Okay, seems like I'm not completely off track here, so let's rerun this image. This should be faster because we just downloaded the Docker image already. And it's installed. So we got that. All right. So let's go back to the repo. Try to understand it a bit more. So we probably want to have some kind of example ligand that we need. So let's go and look at that. This is definitely not perfect. Like, I just need an example PDB-KT file. Let's see whether we can find some kind of example floating around online that we use. It's just then let's see. It's a pretty good resource generally. In the Fisker case, I just want to have an example ligand. Really don't care that much about it. Anything else? Okay, seems like we need to do some of this ourselves. See how things are going. Seems like we're getting an error here. But I just need to agree to the install packages being downloaded. Oh, I forgot the -f flag there. So let's rerun this. we want to figure out how to convert an SDF file to PBQT so we can test our pipeline. I'm going to just quickly check my machine where I have Bobble installed. Yes, seems like I do have OpenBubble installed. So OpenBubble is a tool that you can use to convert between file formats and chemistry. All right, so this, not sure whether this is actually, maybe we just try the same with GPT-4, but so we're here, so we can do OpenBubble, test data, finding, just use P-1, the ligand, and we want to have the output. We want to have 6. PDQT. Oh, I guess we got something wrong here, so use this flag. All right, so we converted our molecule. Let's do this receptor 2. Just convert them both to PBQT. And now we have these 2 over here. Let's open VS Code again. Swapping here our stuff. Let's remove these. Just keep things simple. And that we have license files, the README, nothing that's good to have. And then we're just adding some test data in here, which in our case is already flying around in the repo. Let's use the cell for this. So we have our test data here. We can also visualize them in our protein viewer. So this is visualizing both the ligand and the protein in PDB-QT format. So this seems to not have broken things. Okay, so that. All right. So the next step is we want to see our container finish. How are things going over there? All right, seems like that container has built. And then let's see whether I actually have this container now available online. What do they got? So this is my profile. I'm just seeing whether we have this here. It it doesn't seem to be added automatically. So we probably need to push this container. So we need to probably do a Docker retagging of the container first. It's a bit annoying. So we can do this tagging. So what I'm doing right now is something that hopefully you don't need to do when you're doing this. You're doing this yourself. I think a big takeaway from me here is that we probably need to set up something easier to create these images. So what I'm doing here is I'm just retagging an image. That's something you need to do when you are building with the default Docker reference here. So this will work, and now I can do a Docker push. Okay, so this seems to work. So this is my personal profile. I'm now creating this container. There's quite a big chunky item over here. It's a bit unnecessary that we're pushing this up and down. We just fold it. So I can do something else. I can show in a moment that is using a way, but for I think the overall community, it's probably best if everybody builds the container on the local machine first. Okay. So then let's run one of these containers. It's one, let's run the interactive mode. Okay, so I'm running right now. So I'm now in the container. I did, run interactive. That's how I got it to run. And look in the container. So I got my Uni-Dock. And then basically what I want to run is Uni-Dock. Probably need to give Uni-Dock the right permissions here. Wow. Okay, let's see. What is still? This is expected. Things usually don't go exactly like you want them to. We can also just download the source code and take a look at the source code. Oh man, alright, it's not very informative. No source code. it seems. Okay, so we're really stuck with these binaries. In order to understand this error better. Seems like there's some dependencies that we need to take care of. Let's see whether this fixes the problem. Can also make this whole thing a bit smoother by restructuring the way that we built this container, so we can remove this thing to not work expected, and instead we just rebuild it from scratch. This is the not so fun part. Oh, this is silly. Let's just leave it like that, so we can rerun this quicker. So what just happened was that I installed wget here after I needed wget for rehab, which just makes sense that I got into trouble. All right, so it just built this container again. Just a moment ago. Oh, there we go. Let's do one thing and just make my life a bit easier, and we just built this directly to my personal Docker Hub public repo. So let's see. No, this is actually what we wanted to do. Okay. So let's run this thing interactively. Let's see what we got. Okay, we got Uni-Dock over here. Let's see what's happening now. Okay. We're missing some additional dependencies. I'm wondering also, just looking at this, this function that's Python over here, that maybe when we look at this GitHub repo, we actually also have some dependencies that are not fully clear. The problem with just having the binaries that it's a bit of a really guessing game. It's a bit frustrating. There won't be any sort of additional guide. There seems to be no additional guide to how we figure out how to run this tool effectively. So it remains to be seen, like, how quote unquote open source this whole thing is. I'm gonna just keep working through this. There seems to be like some just C dependencies that are missing that I need to install. And then we'll, I guess, continue later this week, as we're sort of coming up on time and there's a bit more work ahead. So see you all next. I think we're going to do this again on Thursday, where we continue containerizing this tool. It's those C libraries. All right. Talk to you.
Have a good one. I will see you soon.
Yep.